Question number 1. The Taylor series expansion of sin x by x minus pi at x is equal to pi. So, let us take f of x is equal to sin x by x minus pi. We want a Taylor's expansion about x is equal to pi. Now, let us look at this problem. There is a singularity at x is equal to pi. So, we make a small substitution. Let x minus pi is equal to y. This implies x is equal to pi plus y. So, f of x gets transformed to a new function g of y, which is nothing but f of pi plus y is equal to sin pi plus y by y, but sin of pi plus y is minus sin y. So, the expansion of sin x by x minus pi around x is equal to pi is equivalent to expanding minus sin y by y around y is equal to 0. Now, you must remember that about y is equal to 0, sin y has got a power series y minus y cube by 3 factorial plus y power 5 by 5 factorial minus y power 7 by 7 factorial and so on. So, that is nothing but the Maclaurin series of sin y around y is equal to 0. So, when you use that result here, you get minus 1 by y into y minus y cube by 3 factorial plus y power 5 by 5 factorial minus y power 7 by 7 factorial and so on. So, if you simplify, you get minus 1 plus y square by 3 factorial minus y power 4 by 5 factorial and so on. Replace y with x minus pi. So, minus 1 plus x minus pi whole square by 3 factorial minus x minus pi to the power of 4 by 5 factorial and so on. You will find that this part of the series is available in option D. Question number 2. Which of the following functions would have only odd powers of x in its Taylor series about x is equal to 0? The options are sin x cube, cos x squared, cos x cube and sin x squared. So, suppose we take a sin x cube. Now, as already mentioned, sin theta has a standard expansion and we can also look at cos. So, if you take sin x cube expansion, you will have x cube minus x to the power of 9 by 3 factorial plus x power 15 by 5 factorial and so on. So, you can clearly see the odd powers are occurring in the expansion. So, definitely option A should be all right. Then we go to option B, you have sin x squared. Using theta is equal to x squared, you will get x square minus x power 6 by 3 factorial plus x power 10 by 5 factorial and so on. So, these are all even powers. So, this cannot be an option. When you go to C, we got cos x cube. This will be 1 minus x to the power of 6 by 2 factorial plus x to the power of 12 by 4 factorial and so on. Again even powers ruled out. And when you go to cos x squared, we will have 1 minus x to the power of 4 by 2 factorial plus x to the power of 8 by 4 factorial and so on, which consists again of even powers. So, this also is ruled out. So, option A is correct. That means sin x cube is the only function which when expanded in a power series around x is equal to 0 will have odd powers of x. Question number 3. In the Taylor's expansion of e power x plus sin x about x is equal to pi, what is the coefficient of x minus pi whole square? So, this is the center of expansion. So, we know Taylor's expansion is f of x is equal to f of pi plus x minus pi f dash pi plus x minus pi whole square by 2 factorial f double dash pi and so on. So, it is enough to expand till this particular point because we need the coefficient of x minus pi whole square. So, what is needed is f of pi, f dash pi, f double dash pi and so on, which we can easily estimate from the given function. So, let us begin with f of x is equal to e power x sin x and go for two derivatives. Okay. Now, we will estimate f of pi, f dash pi, f double dash pi. So, we will get e power pi plus sin pi is 0, e power pi plus cos pi is minus 1, then e power pi minus 0. So, this is e power pi minus 1 and e power pi. So, let us substitute in the Taylor's expansion formula. E power x plus sin x is equal to f of pi is e power pi plus x minus pi into e power pi minus 1 plus x minus pi whole square by 2 factorial into e power pi. So, the coefficient of x minus pi whole square will be this quantity. So, coefficient of x minus pi whole squared will be e power pi by 2, which is 0.5 e power pi, and you can see this is available as option B. Question number 4. If mod x is much less than 1, cot hyperbolic x can be approximated as, the options are x, x squared, 1 by x and 1 by x squared. So, we have the information mod x is much less than 1. We need an approximation of cot hyperbolic x. So, let us take f of x as cot hyperbolic x, which we can conveniently write as cos hyperbolic x by sin hyperbolic x. Now, we can give the expansions of these two functions as 1 plus x square by 2 factorial plus x power 4 by 4 factorial and so on by x plus x cube by 3 factorial plus x power 5 by 5 factorial and so on. These are the respective Maclaurin expansions of cos hx and sin hx. So, what we do is we retain the numerator, no change. From the denominator, let us extract x, and we will have 1 plus x square by 3 factorial plus x power 4 by 5 factorial and so on. Now, let us invoke this condition, because this is a quantity very much less than 1. So, that means it is very close to 0. Therefore, as x is small, x square and higher powers can be neglected. X may not be neglected, but x square and higher powers may be neglected. So, cot hyperbolic x is approximately 1 plus 0 and so on by x into 1 plus 0 plus 0 and so on. So this becomes 1 by x. So 1 by x is a good approximation of cot hyperbolic x under this condition, and you will find that option C is correct for this problem. Question number 5. For the function f of x is equal to e power minus x, the linear approximation around x is equal to 2 is what? So we want a linear approximation to this function. Remember, Taylor's series can be used to approximate at any level. So let us write Taylor's series for a linear approximation. F of x is equal to f of 2 plus x minus 2 f dash 2 and so on. So when f of x is equal to e power minus x, f dash x is minus e power minus x. So let us calculate f of 2. This is e power minus 2. F dash 2 is minus e power minus 2. Now let us substitute this in this expansion formula. E power minus x is approximately f of 2 is e power minus 2 plus x minus 2 into minus e power minus 2. So therefore, if you take e power minus 2 common, you will get 1 minus x plus 2. So you will get 3 minus x e power minus 2. So look at this, you got a first degree polynomial into some coefficient. So therefore, this is the linear approximation of e power minus x. If the question was quadratic approximation, you extend this series by one more term. Correct option for this problem is A. Question number 6. The series summation n is equal to 0 to infinity 1 by n factorial converges to. The options are 2 log 2, root 2, 2 and e. So summation n is equal to 0 to infinity 1 by n factorial. This is nothing but 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial and so on. You can always remember that 1 plus theta square by 2 factorial and so on converges to e power theta. So here theta is equal to 1. So this becomes e power 1, which is e. So the correct option for this problem is D. Question number 7. A function f of x is equal to 1 minus x square plus x cube is defined on the closed interval minus 1 to plus 1. The value of x in open interval minus 1 to plus 1 for which the mean value theorem is valid is. So there is a reference to mean value theorem. Mean value theorem in differential calculus by default means Lagrange's mean value theorem. So we will invoke the law of Lagrange's mean value theorem to estimate the value of x for which this is valid. So remember, f dash x is equal to f of b minus f of a by b minus a, where a and b are the endpoints of the interval. F dash x is minus 2x plus 3x squared is equal to f of 1 minus f of minus 1 by 1 minus of minus 1. F of 1 means 1 minus 1 plus 1, and f of minus 1 means 1 minus 1 minus 1 by 2. So you can see that this becomes 2 by 2, which is 1. So we are getting a quadratic equation 3x squared minus 2x minus 1 is equal to 0. This can be easily factorized. 3x square minus 3x plus x minus 1 is 0. So 3x into x minus 1 plus 1 into x minus 1 is equal to 0. X minus 1 into 3x plus 1 is equal to 0. X is equal to 1 or x is equal to minus 1 by 3. But we have to make a choice. X is equal to 1 is ruled out because we are looking for the value of x in the open interval minus 1 to plus 1. This is an endpoint, therefore this is invalid. So this is the acceptable solution which corresponds to option B.